Hello everyone, welcome back to my channel. In this video we are going to see how communication setup is established between drive and PLC. We will also cover a small portion of SCADA through which a system is operated in the control room. But our main focus will be on drive and PLC communication, that is start stop command and speed reference feedback and all these things. For this particular video I have taken reference from ABB drive. So let's get started. The complete layout of communication can be seen here. On the left hand side, this is SCADA that is available in control room. In the center, it is PLC or RIO panel, and on the right hand side, that is VFD drive. So here you can see the signals are in both directions. The reason being, from SCADA, the control room operator will give start command, stop command, and even speed reference to PLC, and that reference, those signals will go to drive. And once the drive is running, the drive will generate some feedback, that is speed feedback and current feedback, that will go back to PLC and it will go back to SCADA, that is control room. Even trip indication, running indication, those will go back to PLC and PLC to SCADA. That is the reason the signals are in both the directions. Now let's briefly see the working or use of SCADA in this communication setup. So as we have seen earlier, SCADA is not directly connected to drive, it is connected to PLC and it will send all the required signal to PLC and receive all the required signal back from PLC. So the person who is sitting in the control room has access to this screen, this is called SCADA, and all the things, all the working of any equipment or systems is done with the help of SCADA. So the control room person can see everything that is in the system working or in stop condition. For better understanding of SCADA system, I have taken this image from a running plant. On the top it is mentioned ball mill pumps. So this page indicates or shows the condition of pumps. Here we can see green symbols. So the green symbols are the running pumps of that plant. On the left hand side we can see there are two red pumps, red indication. So those two pumps are in stop condition, and in the center we can see a blue color indication or blue color pump. So that pump is basically ready. Through SCADA, the control room operator have access to all the signal. We'll see one by one. The very first thing is when to start and stop, whether in auto state or in manual state. Here we can see on the right hand side. So after giving a start stop command, the drive is running, we can see. The second one is whether the system is in ready or trip condition. The operator will see that. Third thing is to set reference to drive. At what speed the drive should run. We'll see here. On the right hand side, set point is there. So 85% of the full speed is set by the control room operator. And fourth is to check the speed and current feedback that is coming from VFD in terms of percentage. So by knowing all these parameters, all the four parameters, the control room operator can tell the person in the field that at what speed the drive will run and how much is the actual speed and current of the drive. So this part is being completed. This was our not main topic. We'll come to the main topic, and the very important thing is that the communication here is done with the help of fiber optic cable, which is very delicate. So this part is very complicated, like SCADA part, and the communication between SCADA and PLC is complicated. So we'll cover later. We'll come to the main topic, that is communication between PLC RIO panel to drive. So here we can see the communication between PLC and VFD, that is start stop command, ready trip indication, speed reference to drive from PLC, and current and speed feedback from drive to PLC. So all these four parameters we'll see one by one. First is start stop command, that is coming from SCADA to PLC and PLC to drive. So the control room operator will give the start command and the drive will run. Let's understand like this in this layout. Signal comes from SCADA to PLC and PLC to drive. In PLC or RIO panel there are different slots. Here we are talking about digital input output slot because start stop command, and from ABB manual the digital input 1 is responsible for start stop, we'll see ahead. And in the PLC there is a 5-volt relay which is actuated with the help of transistor. So once the start command is given, this NO becomes NC and the drive start. Further we can understand like this. The PLC on the left hand side operates with 5-volt DC, and on the right hand side in the VFD there is an intermediate relay for safety purpose which works in 110 volt. So 110 volt will go to PLC or RIO panel. So once start command is given, the relay in the PLC, it will get energized and 110 volt will come back to this blue color box in VFD, and here the digital input 1 24 volt get NC and it will go back to drive and the drive will run. We can understand properly in this. So digital input 1, on the left hand side you can see DXXDI block is there, and the first one is digital input 1. So the 24 volt will come here and the green color box is the intermediate relay for safety. Okay, so once 110 volt is actuated, the relay will get the command and the drive will start running. Next is ready, running and trip indication, which are generated by the drive. It will go to RIO panel or PLC through hard wiring, that is digital output, and from PLC to SCADA through fiber optic cable. So in the drive on the right hand side you can see there are three different relays, and these relay will get actuated with the drive situation. If the drive is ready, RX1 will get actuated, and similarly RX2, RX3 for running and trip indications. And on the left hand side you can see if the drive is ready, it will be blue, and if the drive is running you can see the green indication, running indication, and if the drive is in trip condition it will show blank. Now we will understand the same thing with the help of ABB manual. Here you can see the three different relays. First one is ready, RX01. Similarly RX02 if the drive is modulating or running, and RX3 in case of fault. So all these three indications are taken outside to the external relay, and those relay will feed to PLC through hard wiring, and from PLC it will go to SCADA through fiber optic cable. Now we are done with digital input output, and we will switch to analog input part, that is speed reference to drive. So this is a one-way process, that is the signal will come from SCADA to PLC analog input card, and from analog input card it will go to drive slot. Okay, so this is basically at what speed the drive should run, which is set by the control room operator, that will go to PLC, and from PLC 4 to 20 milliamps it will go to SCADA. So here we can see these are the reference point at what reference the drive should run actually, and basically we deal with analog input, that is 4 to 20 milliamps, and this 4 to 20 milliamps comes from analog input card that is available in RIO panel or PLC, and it will go to drive with the help of pair cable, and it will be assigned to AI1 or AI2 as per design. The reverse process is for speed and current feedback to SCADA. So here you can see on the right hand side drive slot EO1 plus 1 minus, that can be used for speed feedback, and similarly EO2 plus minus for current feedback. Same pair cable, it will go to analog card that is available in RIO, and from there it will go back to SCADA. So this is a slide from the manual, you can verify it. Analog output, current percentage and speed percentage, that is sent from VFD to SCADA. So this is how our video is completed. I hope you like the video. If so, please like, share, subscribe, and thank you for watching.